Hello, myself Mohammad Ayaz Khan, Science and Technology Faculty of Next IAS. I am here on a very important occasion to have a discussion on Chandrayaan-3 and the previous programs as well as the future programs related to the lunar exploration, especially of India. And we will be having the simultaneous discussion on some of the major international programs with respect to the exploration of the moon. As you all know, yesterday evening, that is 3 past 6 p.m., we became first country to touch down at the south pole of the moon. And overall, we are the fourth country to land on the moon after US, Russia and China. So in this backdrop, let's have a discussion like what exactly is the structure of the lunar exploration program of India in general, or Chandrayaan in particular, how it has evolved and how it is going to proceed further, and what are the possible benefits we might be having from continuing with the lunar exploration and going beyond the moon, and what are possible linkages it can have with the Chandrayaan mission, or recently India has become 27th country to join the Artemis Accord, which is led by US for the exploration of moon, Mars and the other astronomical objects which are there. See, as far as Chandrayaan program is concerned, see, Chandrayaan of India is having 3 phases. There are 3 phases of Chandrayaan. The phase 1 of Chandrayaan was about orbiter. Now orbiter is something which moves around like this from the pole to pole of the moon. And this Chandrayaan-1 was launched in 2008. So it was only an orbiter, plus it was having a moon impact probe as well. Now moon impact probe, actually moon impact probe is like this, that it's a part which separates from the orbiter and it comes down. And while it is coming down, it collects the data, it gathers the data about the atmosphere of the moon, and eventually it is made to crash on the surface. It is made to crash on the surface of the moon. So this happened. This was this Chandrayaan-1, which was an orbiter, which was the first phase. It was launched by using PSLV-XL. Okay. And it was following the same principle of low energy transfer. Low energy transfer, as we have done in case of Chandrayaan-3 as well, that if this is Earth and this is moon, so PSLV-XL placed this Chandrayaan in a certain orbit around Earth, and then it was following an elliptical path like this. And this way it completed 6 rounds, and when it was making the 7th one, it was taken in the lunar orbit. This is what we call as the low energy transfer. The same has been used here. Whereas if you see Russia Luna 25, they had a direct approach. The only difference is that here the fuel consumption is less, there the fuel consumption is more. As such, there is no qualitative difference which may come out. Then this impact probe of Chandrayaan-1, it was made to crash near the south pole of the moon, somewhere here. And this is the place where Chandrayaan-2 lander and rover were trying to touch down, and unfortunately that did not went as our plan was. So that was Chandrayaan-1. Now Chandrayaan-1, if you see, which was launched in 2008, it was carrying some of the payloads of other space agencies, especially NASA and European Space Agency. And the most remarkable contribution of Chandrayaan-1 was the discovery of water on moon, which was there. So it has discovered water on moon, which was in the form of hydroxyl ion. Yes, that discovery of water was done by an instrument of NASA, and that instrument of NASA was M3, that is Moon Mineralogy Mapper. So this much we need to know about Chandrayaan-1. Then after Chandrayaan-1, we had Chandrayaan-2. So Chandrayaan-2, if you see, that was in July 2019. We had a launch, and this time the fundamental difference between Chandrayaan-1 and Chandrayaan-2, this is the second phase of our lunar exploration, that Chandrayaan-2 was orbiter plus lander plus rover. So if you see, Chandrayaan-1 was orbiter and moon impact probe. whereas Chandrayaan-2 is orbiter plus lander plus rover. Yes, the name of lander was Vikram as this case in Chandrayaan-3, and the name of rover was Pragyan as the case is in case of Chandrayaan-3. It was carried by GSLV Mk3. It was carried by GSLV Mk3. And everything went well till 2.1 kilometer from touchdown. So that is where, lander and rover crashed on the surface of the moon. So this Chandrayaan-2, obviously this part did not went as per our plan, but this orbiter is absolutely fine and is working since 2019. So as a part of the second phase of India's lunar exploration, we have Chandrayaan-3. Chandrayaan-3. Now, Chandrayaan-3 this time, as in Chandrayaan-3, we did not have orbiter. We are not using orbiter. इसमें orbiter नहीं है because orbiter of Chandrayaan-2 was working well. So this time we had a propulsion module, lander and rover. Propulsion module means that module which has carried Chandrayaan-3, lander and rover, after obviously they detached or it detached from GSLV Mk3. Fine, here also we use the low energy transfer like this, but the vehicle was GSLV Mk3. Okay, so propulsion module obviously carried the lander and rover into the lunar orbit. Into the lunar orbit means here, if this is Earth and this is Moon, so GSLV Mk3C carried up to this point, it was GSLV Mk3. Mk3 means Mark 3. And from here onwards, obviously, it was this propulsion module. So here it was propulsion module which was carrying the lander and the rovers. Okay, fine. Then the lander and the rover detached from the propulsion module, and obviously it was like this, then it became like this, it was coming like this, then it became straight, and then after that it came down, and at some height it has to take a call whether to go further or not. And if the decision would have been not to continue further, then it would have moved upward, then further continue this side, and then obviously touch down. But obviously this is how we have planned, and without going into too much of the technicalities which is not needed for our exam, that is the civil services. So then propulsion module, from that the lander and the rover separated, and this lander and rover, this lander, obviously lander is the immobile part, whereas the rover is the mobile part. So this lander carries the rover, and it has landed approximately 69 degrees of the, obviously just close to the south pole of the moon, and it is close to the place where the impact probe of Chandrayaan-1 was made to crash, because we already have the details about it. So with this part, that is the lander and rover of Chandrayaan-3 coming down onto the surface of the moon, and more precisely at the south pole of the moon, the second phase of India's lunar exploration is over. Now let me continue, then I will go to the third part. So if we see, sir, Chandrayaan-3, what exactly it is going to do over there? So the lander and rover of Chandrayaan-3 are going to communicate with the orbiter of Chandrayaan-2. That was the reason there was no orbiter this time. There was only propulsion module. So now let's come to this. Let's come to this Chandrayaan-3. If we see Chandrayaan-3, the propulsion module of Chandrayaan-3 is having only one instrument, one payload, and the name of that payload is shape. That is shape. shape is the name of the instrument or a payload which is on board propulsion module, and propulsion module is still orbiting the sun. After the detachment of the lander, it is still moving in the orbit of the moon, and as per the data put up by ISRO in the public domain, it can continue to orbit the moon for months or maybe years. Okay. So that means if something is moving for such a long time in the orbit of the moon, so obviously it makes sense that we would like to have some benefit coming out of it. So that's why in that propulsion module we have put up an instrument or payload with the name SHAPE. What this SHAPE is going to do? Actually, this SHAPE is going to have some obviously implications for us. This SHAPE basically is related with the discovery of life on exoplanets. So what is exoplanet? See, exoplanet is something which is outside solar system. So how SHAPE is going to work? See, it's like this. We are there on Earth. We means the Homo sapiens. And there are other life forms also. But as far as I know, technology is being used by only one species on Earth, that is us. So it is quite possible, because of life on Earth, there might be certain sort of signals which could be going out in the space or in the universe because of us, and we don't know that. कि हमारी वजह से, इंसानों की वजह से या दूसरे लाइफ फॉर्म्स की वजह से बाहरी अंतरिक्ष में कुछ ऐसे संकेत जा रहे हैं जिनके बारे में हमें नहीं मालूम है. So this SHAPE, what it will do, it will look for those signals which might be specifically because of the Earth going into the outer space. Then after it will detect those signals, then it will look for similar signals coming from the exoplanets. Because if we can find the same thing, which we are fully able to establish is because of life on Earth, and if the similar thing we encounter coming from the exoplanets, then there is a probability and the possibility of the life existing on those exoplanets. Is that fine? Sure. So that's propulsion module. That's why it is going to continue move around the moon. Then another thing here we need to know, like, sir, what about this, lander? Yes, lander. See, lander of this Chandrayaan-3 has got, multiple instruments are there in the lander. So I will just focus on few. So first instrument of lander, on lander, is this. That is ILSA. So what is this? That is instrument for lunar seismic activity. Instrument for lunar seismic activity means it will look to study the seismic events on moon. Seismic event means the quakes and all. Now, obviously, I can't say earthquake on a moon. So what is the future application? See, the future application of this is that if we arrive at the conclusion that moon is very, very stable compared to Earth, then maybe in future, when you people will be very senior officers in the government of India after qualifying this exam, then you will see that on moon we would like to have LIGO. LIGO is Laser Interferometer Gravitational Wave Observatory. In short, LIGO is a setup for detecting the gravitational waves. Gravitational waves, these are the vibrations or the distortions in a space-time continuum, space-time, which is obviously the concept related to the general theory of relativity given by Einstein in the year 1915 to conceptualize gravitation. So those vibrations in the space-time we call as gravitational waves, and to detect those gravitational waves, the system we are having on Earth, like one is coming up in Maharashtra at Hingoli, is LIGO. So we would like to have the same thing being there on the moon, so we can detect more and more gravitational waves and have the better understanding about the many things which exist in the outer space. So again, here you can have an idea that, sir, we are not looking only on moon. Here we are looking for the possibility of life on exoplanets. Here we are looking to detect the gravitational waves, which primarily are there because of the collision of the black holes. Plus there are reasons like neutron star and the black hole plus pulsars responsible for those gravitational waves. So now you can imagine the ambit of the research which Chandrayaan-3 is having. Okay, so I want you to have that perception. Second thing is there is a probe called Rambha. This is an instrument on the rover. Okay, then there is a probe called Langmuir probe. Langmuir probe. These two will do only one job, same job, Rambha and Langmuir probe. Okay, so remember, now I am talking about the payloads on Vikram, the lander. They will study the plasma, presence of plasma on the lunar surface, So why we are studying the plasma on the lunar surface? It's very simple. From where this plasma is coming, obviously plasma is coming from the outer space. What is the significance? See, plasma is charged particles. So these in future, like Artemis Accord, which is there is an initiative of USA, which talks about the permanent presence of man here does not mean gender, human beings on moon. So if I am looking to have permanent presence of man on moon, I would like to see how suitable the surface of the moon is as far as sustaining the human beings. And for that, one of the things we are looking to do is to study the presence of the plasma near the surface of the moon. So these two will study the plasma. Then there is another probe on lander called CHASTE. This probe, like you will read in the coming days, it will drill into the lunar soil up around 4 inches or 10 centimeter, whichever you like. No need to write this. And then it will study the thermophysical properties. So these 4 are on lander. ILSA, Rambha, Langmuir probe and the CHASTE. Then obviously comes the probe. So in total Chandrayaan-3 has 7 instruments. So I have already told you about 5. Now 2 are left. For that I am going to change the slide, and yes, I will tell you that why it will work for 1 lunar day. Now comes to the instruments on the rover. Let's talk about rover. Rover, we all know the name is Pragyan. Rover obviously is going to move on the surface, whereas lander is immobile. And both lander and rover will work for 1 lunar day, and which is equal to 14 days on Earth. So that is it. Sir, why it will not be able to work? Because sir, it is solar panel powered. So when there will be lunar night for 14, obviously equal to the 14 days on Earth, there will be no sun available. And during lunar night, the temperature goes well below -100 degrees Celsius. So yes, when the sun will again arrive, the solar panel will start working. But once the temperature will be so low, like it will be around -280 degree Fahrenheit, then the instruments, the electronic systems and all will not be able to work again. So the best bet lies obviously for 14 days. Yes, you can argue, sir, we could have used RTG like Russia was having in Lunar, that is radioisotope thermoelectric generator. Yes, if you are using RTG technology, then you are not obviously going to suffer because of extremely low temperature during lunar night, because RTG keeps on producing the heat which keeps the instruments in the working conditions. So basically, as of now, ISRO and BARC together are working on this particular technology, and in future you might see Chandrayaan 4, 5 onwards we might be using RTG. In that case, the restriction of the one lunar day will be gone. Okay, so but just a brief idea that what happens, how come this RTG technology work. In RTG, we take some radioactive substance like say plutonium-238, and this it emits alpha particles, and these alpha particles obviously have the heat, and this heat is used to generate the current. By using something called Seebeck effect. Seebeck effect, like which is like using heating effect to generate the current, and this current obviously will keep the instruments working when the sun is not available. So Lunar 25 was using this, but this is not the case with Chandrayaan-3. So that's why they will work for one lunar day. Maybe in future, as I said, ISRO and Embark, they are working on it. So hope so that the future missions of India's lunar exploration have the RTG technology, and there our lander and rover can work for longer durations. Now come back. So I hope now we have some idea. Now this rover is having two instruments. First is APXS, that is alpha particle X-ray spectroscopy. And the other being LIBS, that is laser induced breakdown spectroscopy. Laser induced breakdown spectroscopy. Now, spectroscopy is the science of the chemical analysis, because different chemicals interact with different electromagnetic radiations or at different frequencies and the wavelengths. So here both of them, APXS and LIBS, will carry out the chemical analysis of the lunar soil. So they will be performing what we call as the chemical analysis of lunar soil. That's it. That's the main job. That's the main job, because this is a rover, it will be moving. So when it will be moving, obviously it will be analyzing the samples at the different places, whereas rover will be confined to one place. So there is obviously not much of significance if we just do the analysis for one part. So this way, this way we can find out what all minerals are present in the lunar soil. What all minerals are present in the lunar soil, and in future you never know. This is how we might be starting space mining. Space mining means bringing the minerals like rare earths from the moon. As per the Space Policy 2023 adopted by the Government of India, we have obviously allowed or permitted our private sector to indulge in space mining. So yes, these are still early days. And you all know it does not happen overnight, but somewhere we have to start. So we have started working with Chandrayaan. That is why the landing of Chandrayaan-3 yesterday was so crucial. It's not for optics alone. Come on, sir. It's not for optics. It has some serious science to do, and that is the serious science. And obviously this science will move the economy of the country in future. And if the economy of the country is going to move in the forward direction, that means we all are going to benefit from it in one way or the other. Yes, I will have one more benefit. The more such projects are being there, so more content I have to discuss with my students in the class. That's obviously one additional interest I have in such missions and the projects. In general, obviously, everybody is going to benefit from this. That's why we need to continue. And moreover, see, the missions like this to a country like India, we are a developing nation. When we come up, like these are the early days for such missions. So when you start early and you establish yourself firmly like India has been able to do so, then it gives you that bargaining power when you sit on the table with the other countries like US is sitting or Russia is sitting or maybe European countries, and you never know, maybe China. So that gives you that bargaining power. So we also have something serious to contribute. It's not like we are looking at you only. So this sense is very much important, कि हमारे ऊपर भी तुम dependent हो. Yes, got my point? So that's where this was very important, and you can see from the reaction of the officials of ISRO yesterday, they really wanted it to happen successfully, very, very, very eagerly I will use the word, not desperately. चलिए आगे बढ़ते हैं. Let's proceed further. Now, what about the third phase of the Lunar mission? No, that is the third phase. See, the third phase will be about the joint exploration of Moon. Joint exploration of Moon. And here there are two things. First will be ISRO and JAXA. JAXA is Japanese Aerospace Exploration Agency. JAXA is the name of the Japanese aerospace. So they have come together because India and Japan are having a space dialogue. India, Japan, space dialogue since 2019. So as a part of Indo-Japan Space Dialogue, ISRO and Japanese Aerospace Exploration Agency, they have come together. And 2025, as of now it is 2025, India and Japan will be sending a rover to the south pole of the moon, and that is LUPAX. So LUPAX is Lunar Polar Exploration. Lunar Polar Exploration. And this lunar polar exploration will look for the frozen water, or will study frozen water at the poles of the moon. At the poles of the moon. That is the third part. Another part which I'm saying, this is my interpretation, will be this thing, that India has joined Artemis Accord. So in future, the lunar exploration will take different direction. Artemis Accord. So India has become the 27th member of Artemis Accord, the others being US, Japan, Israel is there, South Korea is there, Australia is there, and there are other countries also, Luxembourg, New Zealand, there are many countries, Artemis Accord. And this Artemis Accord talks about like having the permanent station at the moon. And most probably that permanent station is going to come up at the south pole of the moon. And that is where obviously NASA is planning, as a part of Artemis, NASA is planning a lunar space station gateway. Gateway is the lunar space station, like they have the space station on Earth. Similarly, there will be a space station on the moon, and it has been named Gateway. And they are even planning a navigation system for moon. And there will be continuous to and fro movement of the human beings from Earth to moon and vice versa as well. That is a part of the Artemis Accord. Yes, this will one day take towards the space mining also. So that will be the third part, and let's see how it continues further. So some of you will say, sir, why India is not going alone? See, actually, it's a very, very expensive, endeavor. And even the best biggest of the space agencies, like you can imagine the budget of NASA or the European Space Agency, or even China and Russia have come together, and China and Russia are planning International Lunar Research Station at the south pole of the moon. Even they are coming together. So it will become very tough for any single space agency to be able to mobilize both man and the material at its own for such long-term missions. So it's this here onwards, the outer space exploration is going to be more and more towards collaboration rather than individualistic efforts by the respective countries. So that is one of the reasons India has joined Artemis Accord. Besides that, it will allow us to have our startups being a part of the global supply chain. So that will help them to grow financially as well as technology wise. So there are multiple benefits that will come out of India joining the Artemis Accord. So as of now, this is like how things are going to. So this is the future part of the lunar exploration. And if you see, this is the current part of the lunar exploration, and this is the past of the lunar exploration. So we have discussed the past, the present, as well as the future of the lunar exploration. But as I say, the story is not yet over. So then some of you will be having, sir, why South Pole of the Moon? So let's continue. Why South Pole of the Moon? See, South Pole of the Moon, there are 2-3 reasons why we have gone for the soft landing at the South Pole of the Moon. See, South Pole, there is frozen water. There is frozen water. There has been estimation by, Chandrayaan-1, then Chandrayaan-2, others as well, that there is approximately 600 billion kilogram, not liter, of frozen water at the poles of the moon. Poles of the moon. And there are many, like if you say, NASA is having a program, Trailblazer. This will also look for studying only what we call as water. Then NASA will be sending one rover to the moon named Viper. No, it's not the Viper which crawls on the surface. This Viper will be a rover and it will be moving on the surface of the moon. This Viper will also look to study the water. But this time the water it will look to study will be the subsurface water. So one theme which is coming out after the space mining is the water. So our next area of interest on moon is water. No, we are not looking to bring this water obviously on Earth for the drinking purpose, because that's going to be too costly. Fine. तो फिर सर इसका क्या करेंगे? अभी बता रहे हैं, अभी देखते हैं ना. Let's see frozen water. There is a lot of water, huh? Then if you say, LUPAX, Chandrayaan-1, Chandrayaan-2, now Chandrayaan-3. Chandrayaan-3 as such is not studying water. See, our plan is that at the south pole of the moon, near the south pole of the moon, there are mountain peaks. And they receive sunlight almost throughout the year. So the thing is that on these mountain peaks, we will have the solar panels, and then we'll take out the water, and this water will be broken down to produce hydrogen and oxygen. Also, sir, hydrogen लेके आएं, come on, green hydrogen नहीं लेकर आ रहे, रुक जाओ. And in future, moon will be used as a halting point for manned interplanetary missions. Like say for example, we are going to send human beings to Mars. Obviously the distance between the Earth and the Mars is so big that we have to carry a very high quantity of the fuel, and that increases the cost exponentially. With the current technologies going to Mars, you need $1 trillion, which even Uncle Sam is not thinking about. Uncle Sam means US is not thinking about. So we want that, like, we'll give fuel to the vehicle and it will touch down on the moon, will again get the fuel and proceed further to the Mars, and while coming back from the Mars, will stop at the moon, get the fuel, that is hydrogen and oxygen, and come back to Earth. So that's the next part, why we have gone over there. Then another reason we have gone for the moon is a south pole of the moon, is that at the south pole of the moon we have a very deepest crater in the entire solar system, and that is Ayaz Basin. In this Ayaz Basin, that the material from the crust and the mantle also came out. So in the future programs, you will find the future missions to the moon by ISRO, maybe individually or maybe joint operations. You will find that some of them are going to be sample return missions. So we are going to bring the material from the moon, and one of the areas we are going to bring the material will be the Ayaz Basin, because here we are not going to get the material only from the crust. We are going to get something from the mantle also. So that will be the part of sample return mission. Sample return mission is space mining. Now these materials can be used for multiple purposes. Like we can calculate the age of the solar system. We can understand the process of the formation and the evolution of the moon, and we can also understand the process of the planetary formation. Besides that, one more reason of our interest in moon is helium-3. Helium-3 is maybe going to change the dynamics of the energy production of the world in the future. As you all know, India has announced 2070 to be the year for the net zero. So one of the alternative source of energy we are looking at is the fusion power, not fission, fusion. India is already a part of an international program, ITER, International Thermonuclear Experimental Reactor, which is coming up in France. So as of now, ITER requires tritium. Tritium is 1T3. And tritium is radioactive and it's a costly, isotope. So the plan is to bring helium-3 from the moon and replace tritium-3 over there. Because helium-3 is non-radioactive, and if it is non-radioactive, then you do not have to worry about the reduction in the quantity over a period of time. So these are like the possible, benefits we are looking at by exploring the south pole of the moon. So this was my humble effort to discuss, obviously, some of the aspects of India's lunar exploration. I hope and I wish I have given you a point or two which you were not knowing. So in future, obviously, I would like to have the similar recordings for Chandrayaan 4, 5, 6, 7, 8, 9, 10 and so on and so forth. So thank you very much for this. All the best and Jai Hind.